I'm Anil Kumar. Welcome to my series on trigonometry. In this video, we'll try to understand transformation of parent trigonometric function sin x. Once we understand all this, we'll be in a position to sketch graph of some transformed trigonometric functions. That will be our next video. Now, to begin with, we'll consider one cycle, just one cycle of a trigonometric function. That means the x value will vary from 0 to 360 degrees. And we'll also consider the parent function as sin x and the transformed function as a sin k x minus d plus c. So these parameters a, k, d and c may cause vertical and horizontal translations, compressions, stretches and reflections. When what happens is what we'll see. To begin with, let's try to understand what is sin x itself. So first let me just sketch the graph of sine function and then write down the key parameters. Sine function is a graph like this, sinusoidal wave called sometimes, correct? So that is how it is. Now when we say sine function, we begin with 0. So let me draw an axis which goes kind of like this. At origin, the value is 0. We know this is what we are calling sin x. Right? So this on axis, x-axis, we are working on in degrees. So for sine, the maximum value is 1. The minimum value is minus 1. This time period, one full wave, right, that time period is 360 degrees. So at 180 degrees, it is 0. At 0, it is 0. At 90 degrees, we have value of plus 1. At 270 degrees, it is minus 1, right? And it gets back to 360 degrees. So let me write down all these key points for sin x. So if we consider sin x, then for different values of x in our given domain, we'll consider at 0 degrees its value is 0, at 90 degrees it is positive 1, at 180 degrees it is 0, at 270 degrees it is negative 1, and 360 degrees it is back to 0. So that is one full wave. So in all the transformations, we will see how these coordinate points. So as a coordinate point on this graph, I may at times use 0, 0, right? So all are in degrees, or sorry, this is the value 0, right? 90 degrees and 1, 180 degrees 0, 270 degrees minus 1, and 360 degrees 0. So those are the values for different x values. Perfect. So we'll consider what happens to these values. How do these points? So in general we call them x and y. So now let us see how these coordinates, x and y coordinates, change when we have a transformed trigonometric function. So we'll consider one by one all the cases. Now let us first consider horizontal translations. So the transformed function g of x is normally written as a sine square brackets k times, you have to factor out the coefficient of x. That is kind of very important, right? Okay. The parameter which results into horizontal translation is d. So in case d is greater than 0, that means it is positive, in that case g of x translates d units right. And if d is negative, in that case the transform function translates d units left. That means what? It really means that because of this, domain will change. Correct? And because of this translation, we at x equals to 0 will not have sine x as 0. There will be a phase shift. However, the shape and size will not change. So generally speaking, if the graph of the function is default is sine x like this, then in that case, horizontally the whole wave will move d units right if d is greater than 0, or it is going to move d units left if d is less than 0, right? So this thing is the phase shift, left or right, depending on the value of d. Perfect. So to give you an example, if I have a function y equals to sine of x minus 30 degrees, that really means that the graph will shift 30 degrees right. And if we have y equals to sine of x plus 45 degrees, in that case, the graph will shift 45 degrees left. Is that clear? So these are the two examples to illustrate. Perfect. Now let's see what happens, which parameter changes when we are looking into vertical translation. The vertical translation is because of the parameter c. So if c is greater than 0, in that case g of x translates c units upwards. And if c is less than 0, in that case g of x translates c units down. So what we're trying to say here is something like this. If we have graph of sine x as kind of like this, in that case, positive value of c means this axis moves upwards, and we will have a graph which could be like this. And a negative value means that c will move downwards and the graph will be kind of like this. You get the idea, right? To give you an example, just as we did earlier, y equals to sine x plus 5, for example, we'll move this to 5 upwards, and y equals to sine x minus 3, we'll move this to minus 3. Does make sense to you? So again, in this particular case also, the position changes. Right? Range changes. Correct? The other things more or less remain same. Is that clear to you? Perfect. Let's move on and take another example. This time we'll consider vertical stretches and compressions, which is because of A, this parameter. So here we'll consider two cases. One is when A is positive, the other one when A is negative, less than 0, right? So we'll have two cases here. One when A is negative. The other one will take when A is positive, correct? Now if A is negative, in that case, basically what happens is that the graph, which is kind of like this, gets reflected. So that means reflection, we sometimes say vertical reflection, on the x-axis. So the graph of this function will be kind of like this. So the reflection will be for an equation like minus sine x, right? So if I have y equals to minus sine x, the graph will be reflected on the x-axis, right? As shown here. Now, whether it is less than 0 or greater than 0 will have two conditions, and that is, we'll have absolute value of a which could be greater than 1, or we could have absolute value of a less than 1, right? That will result into stretch, and this will result into compression. We'll see both with reference to this side, a greater than 0, right? So let's consider the case when absolute value of a is less than 1. Basically, we are trying to say that the value of a is less than 1 but is greater than 0, right? That is one case. The second case is when absolute value of a is greater than 1. That is to say, a is greater than 1, right? If a is greater than 0, right? Anyway, the idea here is that if the absolute value of a is less than 1, we get vertical compression. But if the value, absolute value of a is greater than 1, in that case we get vertical stretch. To give you an example, y equals to 2 sine x, for example, will be a vertical stretch. So if you have y equals to 2 sine x, in that case, if the graph of sine x is kind of like this, then y equals to sine 2x will be like this, right? So the amplitude will now become 2, right? And that is how it is going to be. For a case when the vertical stretch, when the value of a is, let us say we have y equals to half sine x. In that case, if the graph of sine x is like this, then half sine x will be, every point on y will be half units away of the original. At x, they will have the common point, right? As seen here, right? Now, if it is a is negative, of course, this will be flipped over the x-axis. So what you notice here is that the a parameter changes the range and also the amplitude. We'll actually see combination of all of them later, right? Now let's talk about horizontal reflection. Now when we say horizontal reflection, then we may have an example as y equals to sine of minus x. Now in case of sine of minus x, what really happens is that a graph of sine x, which is kind of like this, will get reflected on the left side on y-axis, right? So what you get here is something like this. Now if you're working with cosine function, in that case cosine function is even, right? So if I have y equals to cos of minus x, the graph is more or less same. Only thing is, if you're considering one wave, in that case, the domain will change, right? If you're considering one wave. So that will be cos of minus x, right? Now, at times, we may actually convert this cos of minus x to cos x and may sketch like this also, right? That we may do. However, when we are restricting ourselves to the interval when x is between 0 degrees to 360 degrees, in that case, when you do minus x, right? So when I do minus x, then the signs change. Do you see that? The signs will change, correct? And you'll have minus 360 degrees to 0 degrees. So the domain changes, right? So for a reflection on horizontal axis, domain changes. Especially when we are working on a fixed interval. So that is very important to understand. Now let us consider horizontal stretches and compression. In the transformation, g of x equals to a sine k x minus d plus c, the parameter k compresses or stretches horizontally the graph of sine of x, right? So let's try to understand what really happens in this case. So let's take an example. Let's say we have function g of x equals to sine of 2x. So when we have sine of 2x, then the sine graph, which has a cycle of 360 degrees, it actually compresses, and we'll get two waves within this period, right? So one will be kind of like this, the other will be kind of like this, right? So we have two waves within this. So when the value of k is greater than 1, in that case we get horizontal compression. By a factor of half, right? So basically, one wave will now be from 0 to 180 degrees. So the time period changes, right? So the time period t is normally given by 360 degrees divided by k. So that is how it is. K also gives you number of waves in 0 to 360 degrees, right? So number of waves. So we have sine 2x, there will be two waves within 0 to 360 as shown here. Does make sense to you, right? Now on the other hand, if I have h of x as equal to sine of half x, that really means that there will be only half wave within 0 to 360 and a full wave will have a time period of 720. You get the idea, right? So if we have sine of half x, in that case we'll have a time period of 360 degrees divided by half, or you can say 720 degrees, right? So it gets multiplied by. You get the idea, right? So it is in general, always you need to divide 360 by k to get the time period. Perfect. So if k is less than 1 but greater than 0, or we could say absolute value of k is less than 1, in that case we have horizontal stretch. By a factor of 1 over k. Is that clear to you, right? By a factor of 1 over k. Now we are going to combine all this learning and then take up examples. Now before that, here is a question for you. One cycle of f of x sin x to g of x a sin k x minus d plus c. Which transformation changes shape? So, as we have seen earlier, the transformation which changes shape is a or k, right? So if a is not equal to 1, right, or if k is not equal to 1, let me write absolute value, right, is not equal to 1 or k not equal to 1, in that case shape changes. We get stretches or compressions. Correct? So the parameters which will change the shape of the graph are a and k, right? The next question on the same line is, which transformations change location? So the translations up or down, right, which is because of what? Because of C. Or you can say left or right, which is because of D, will change location. Clear? Perfect. Now let's take an example to end this video. I've taken an example of a cosine function. So if the function is cos x and we are working for one cycle between 0 to 360 degrees, we are given the function g of x, which is minus 5 cos 2 x minus 30 plus 2. How will the transformations take place? Let's try to understand this. So in this, the negative here reflects what? That means it is reflection on x-axis. At times we say vertical. Reflection on x-axis. Y gets stretched by a factor of 5. So this 5 here represents vertical stretch by a factor of 5. The parameter 2 represents horizontal compression by a factor of half, right? It results into time period change, right? So here the time period will become 360 degrees divided by 2, which is 180 degrees. Here the changes of amplitude A becomes 5. Do you see that? Now, the parameter which is minus, and here we have 30 degrees, it is a phase shift. 30 degrees right. So that is a translation. And the last parameter represents vertical translation of 2 units. That changes the axis. So axis of the graph will now become y equals to 2. Is that correct? Let us summarize the transformation of points. What I mean to say, if we have x and y coordinates, then because of this transformation, the x values will get divided by 2, right? And then you have to add 30 degrees. As far as the y values are concerned, they get multiplied by 5 and then you add 2. So that is how the points will change on the graph. Does make sense to you? Correct? So that is how the points will change on the graph. Now, based on this, you have a question. The question for you is find domain and range of this function. Clear? So that is your question to do. We'll actually take all our learnings to the next video and answer this particular question, where we are going to sketch the graph and understand the transformations which we have talked about in this particular video. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.